Welcome to my very first video ever. We're going to be looking at solving systems of equations by graphing. Now we're going to be looking at solving linear equations. So we're going to be looking at something that looks something like that. But you could also have a parabola and a line, okay? Or you could have two parabolas. Or you could even have three lines. Okay. But when you're solving a system of equations, what you're looking for is you're looking for the points that they have in common. So I've put the answers to these systems in blue. So those would be what you would be looking for when you solve a system. Here's what we're going to be doing this year. We're going to be basically just looking at two lines and the one point that they have in common. Here I've listed the steps for solving by graphing. First step is to graph both equations on the same coordinate plane. Secondly, you're going to find the point where they intersect. Third, you're going to name the intersection as a coordinate point, so you're going to write it as x comma y. And the last, most important thing is you're going to check your solution in both equations. You can do this very easily just by plugging the numbers in. So I'm going to show you how to do that in the first example. Our first example is 2x minus y equals 3 and x plus y equals 3. We're going to first graph 2x minus y equals 3. In order to do that, I need to get y by itself, so I'm going to subtract 2x. I have negative y equals negative 2x plus 3 because I'm putting it in slope-intercept form, y equals mx plus b. Then I need to get rid of the negative in front of the y, so I'm going to divide everything by negative 1. So I get y equals 2x minus 3. Becomes a minus because I have to distribute the negative into both terms in my numerator. Now I'm going to graph this equation. So I'm going to go down 3 on my y-intercept, my y-axis. And then my slope is 2 over 1, so I'm going to go up 2 and over 1. And up 2 and over 1. And up 2 and over 1. And then I'm going to make the straightest line I can. I recommend you use a straight edge, but I don't have one, or I don't know how to use it. Okay, the next line I'm going to do in green. So I have x plus y equals 3. So to get y by itself, I'm going to subtract x. And I get y equals negative x plus 3. So I'm going to start up 3 on the y-axis. And then my slope this time is negative 1 over 1. So I'm going to go down 1 and over 1. And down 1 and over 1. And you can see, because I did lots of points, you can see exactly where the lines cross, even if you don't make a straight line. You can see exactly where the points cross, which is right here. And then step 3 was to write that point as a coordinate point, and that is the point 2, 1. Okay, so I've copied my solution onto the next slide here, and here I got 2, 1, and I want to check that now. So you're going to take 2 and you're going to plug it in each time you see an x, and you're going to plug in 1 for every y that you see in each equation, and you're going to make sure that it comes out right. So I'm going to take 2x minus y equals 3, and wherever I see my x, I'm going to plug in 2. So it's going to be 2 times 2 minus 1 should equal 3. So 2 times 2 is 4, minus 1 equals 3. That's true. So I've checked my first solution, my first equation. That one's good. Now I just need to check the second equation. The second equation was x plus y equals 3, and I know you guys are very quick and you could do this in your head, but I'm just showing you the steps. So I'm going to plug in a 2 for x plus, and then my 1 for y, and that equals 3, which is also true. So I've done the most important step, which was checking. Most important.